Hello everyone, so today is our day 7 and today we are going to discuss about full subtractor. So first we will understand a little bit about theory and then we will move to our Verilog coding. So this is the block diagram for full subtractor. In this full subtractor we have three inputs A, B and B in, and there are two outputs difference and borrow. Okay, in the last video we discussed about half subtractor. In that we have two inputs and two outputs difference and borrow, right? So this is also the same. See here in this circuit diagram you can see this part, this XOR and this NOT and AND gate. This part is nothing but the half subtractor, okay, and this remaining part is another half subtractor. So by combining two half subtractor we can make one full subtractor. Okay, so this is the circuit diagram for this full subtractor. So some interviewer may ask what are the gates you are using in this full subtractor. So we can say two XOR gates, two NOT gate, two AND gate and one OR gate. These are the gates we are using in this full subtractor. And this is the truth table for full subtractor. In this full subtractor we have three inputs. So how many total combinations can possible? That is 2 to the power 3. It means 8. So we have here 8 combinations, right? From 000 to 111. So we will write first Verilog code for full subtractor, then we will verify each combinations. We are getting same, we are getting exact output or not based on this truth table. Okay, so let's move to the Verilog coding. So first we need to create source, create file, write file name. So I am writing fs, that is full subtractor, finish. Okay, I will keep module name is same, fs. And here our file is created. So write it here, inputs and output ports. Input A, B, B in. And for output D, B. Okay, so these are the inputs and output ports. Sorry, here we need to write some different name. If we will use the same input and for input and output, if we will use the same name, then here warning is coming, right? So we need to write something. So just I will write B out. Okay, next, so I will write by using data flow modeling. So what is the expression for this difference? Assign D equal to A XOR B XOR B in. Okay, and for borrow, that is B out, assign B out equal to negation of A and B, or negation of A and B in, or B and B in. Okay, so these are the two expressions for difference and borrow. Okay, so this is our Verilog code for this full subtractor. Let's save this. Now next move to the Testbench part. Here create simulation sources. Next create file. I will write this name fstb. Finish. Module name I will keep same. And here our Testbench file has created. Okay. Okay, so so let's write our Testbench. For input range A, B, B in, same whatever we discussed till now we need to write in that same way. So wire D comma B out, this for the inputs and outputs. Next we need to instantiate our module which we wrote for our full subtractor. So this module, what is the name? FS. So FS, just write instance name. Next from here we need to pass what are the input and what are the outputs. Next here B. Okay, next write initial, begin, end. Then inside this we need to pass our inputs, right? These things we already discussed. So initially we will keep A equal to 0, then B equal to 0, then B in equal to 0, then after 10 seconds A equal to 0, B equal to 0, B in equal to 1, and remaining possible combinations that we saw in that truth table. So we need to write all those combinations. Okay, so I will write it. So here I wrote all possible combinations. Then after 10 seconds we can write finish, $finish. Okay, so this is the test bench. So let's save it. Initially there was 2 files. Now here after instantiation we have 1 file, right? So that whatever we wrote, that file, Verilog file, it come under this testbench file in this simulation part. Okay, so let's simulate and verify our design. Okay, so let's see here. This is our simulated result. So here you can see that for 000 case, this output D and B out is 0 0. Okay, so similarly we will verify other possible combinations from truth table. Here is our truth table. For 000 case, our output is 00. For 001, 11. For 001, it's 11. Next, for 010 case, for 010 case, 11. See, 010 case, 11. Next, for 011 case, 01. 011 case, 01. Next, for 100 case, 10. 100 case, 10. Next, 101 case, 00. 101 case, 00. Next, 110 00. So 110 00, and for 111 output is 11. For 111 output is 11. So in this way we verified our full subtractor by doing simulation. Okay, so this is about full subtractor. We discussed little bit theory, and then after we wrote Verilog code and we simulated and we verified whatever we wrote our Verilog code, that is correct. Okay, so we will see few more questions. So we will discuss few more circuit in the upcoming videos. Till that, thank you.